Finally, our last page, question 5 says, for each of the following relations, determine the missing inputs or outputs. If no input or output is possible, explain why not. So in this first one, you can see we've got the value of 27. It's going to land in this function, and when I do, it's not necessarily an attractive situation. I've got the square root of 47 in my numerator and the number 7 in my denominator. It turns out most of you quickly evaluated that with your calculator, and you saw that the square root of 47 was approximately 6.85. So for you to round it, approximately 6.9. And if you divide that by 7, let's see, 6, oops, let me do that on my calculator here. Divide by 7. You get approximately 9.8. So that was a fine answer I was looking for, about 9.8. Some of you said approximately 1, and that's okay as well. But that's most definitely what you get. You get something very near 1 when the input there is 47. On this next one, what value can you cube and produce an answer of 8? So if you look at it, we're looking at this, and what value times with 3 factors of that value will produce 8. Unfortunately, we've been looking at this a lot, and we know that it's 2. 2 times 2 is 4 times another 2 is 8. So on this one, the input would have been x, and over here the output is approximately 0.98. On question 6, we're given 2 relationships and asked to identify if they're functions. Functions or not functions. And if they're not functions, we're asked to give at least one example of an input that does not have a consistent or predictable output. So this is the thing we're looking for, right? Are the outputs consistent and are they predictable? Well, when I look at part A, every single one of these outputs, you can see 1 is always producing an output of 3. As I look down this table, I never see an input of 1 produce anything other than 3. So that's consistent and predictable. When I place 3 into this function, it's consistently and predictably producing the value of 1. 5 is always producing 4, and there's 5 is never producing another value. 6 is always consistently and predictably producing 3, and 8 is consistently and predictably producing 1. Now, if I was to modify that, this is not the problem, but if I was to say, for example, oh, here's 3, and let's say that it produces a 7. Well, this is no longer a function because you can see this input 3 sometimes produces 1, and sometimes it produces an output of 7. So that's not a function. But this, as it is clearly a function because all the inputs are consistent and predictably, you can predict what the output is each time. So this is a function. The next one, however, is not, and we'll just consider the case of when x is negative 2. So you can see if I place x is negative 2 into this function, there's 2 things that happen. I can get an output of 2, and I can also get an output of 4. So this is not a function that it's a relationship but not a function, because negative 2 is not consistent. It's not producing consistent and predictable outcomes, right? Negative 2 sometimes is producing 4, and sometimes it's producing an output of 2. So this is not a function. And it does ask you to identify why. So I would say, hey, look, negative 2 produces an output of 4, but negative 2 is also producing an output of 2. So that is not consistent and that's not predictable. And then finally questions, well actually there's 7 and 8. In question 7, we're just going to quickly place in some values here for x. You see we're going to place in x is 0, x is negative 2, and x is positive 4. When I plug in x is 0, this becomes 0 minus 4 in parentheses, which is negative 4. And when I square negative 4, that is negative 4 times negative 4, which is positive 16. So this is producing positive 16. And the next one, when I place in negative 2, you can see this is negative 2 minus 4, which becomes negative 6. Again, we're squaring this. And when I square negative 6, that is negative 6 times itself times another negative 6, which produces a positive 36. And then finally, when I place 4 into this machine, it ends up becoming a 4 minus 4 squared, which is 0 squared, and 0 times 0 is 0. So the output there is the number 0. Then finally, question 8 asks us to explain the difference between 3m cubed in parentheses versus 3m to the third power. And really the difference is what's being cubed. In this first case, the thing that's being cubed is 3m. So if I was to write that out, 3m cubed is a 3m times a 3m times a 3m. And if I look at this, right, 3 times 3 is 9 times another 3 is 27. This is 27m to the third power. So the 3 and the m are both getting cubed in the first instance, right? This is what 3m in parentheses cubed is. And the second one, what's getting cubed is just m, right? That's just a 3 times a factor of m times a factor of m times a factor of m. So really it's the same thing, right? It's just 3 and then 3 factors of m, 3m cubed. So again, the difference is what's getting cubed. In the first case, 3m is being raised to the third power. In the second case, just the m is being raised to the third power. Okay, so that's it for the study team test for Chapter 1.